Beijing, booming capital of a new superpower. Once a city of bicycles and empty boulevards, now changed virtually beyond all recognition. 3.5 million cars, citywide traffic jams. Beijing has added 1.5 million residents in the last year alone. The city is growing faster than its infrastructure can support. Enter a solution on a gigantic scale. The biggest subway in the entire world. Beijing's 8 metro lines will grow to 19. 400 kilometers of new subway will be built underneath the city. Cutting-edge security will keep passengers safe in 200 new stations. A state-of-the-art signaling system will revolutionize the way trains run. As the Dragon roars into the future, it needs this subway more than ever. But can Beijing's engineers rise to the challenge? The world is watching. The Beijing subway is a world record breaker, the biggest system ever designed. From 200 kilometers today, the metro will grow to 560 kilometers, and it will be done in record time.
First feeling is that they are crazy. It's impossible to do that. But I think impossible is not Chinese. If they want to do it, they will do it.
Sophisticated new trains will serve futuristic stations. Innovative technology will create what is possibly the world's safest, most efficient, and profitable transport system.
I think by 2015, Beijing subway will be not only the biggest, but also the best.
In many great cities, the subway came first. The metropolis grew up around the metro. New York's underground tracks were laid when parts of Manhattan hadn't even been built. But Beijing has been here for centuries. It is no blank canvas. And the metro's chief engineer, Yang Shu-run, knows that is a problem.
People think the construction of subway is easy because they're underground and they don't have anything to get in their way. This isn't true. We have lots of things to take into consideration.
To come up with the route for Beijing's 17 new lines, city planners had to consider: where is Beijing's worst traffic? Where do the most people live? The 400 kilometers of new tunnels also had to be built avoiding the huge foundations of skyscrapers and fragile ancient buildings. One example demonstrates how flexible they had to be.
Line 8 runs along the axis of Beijing. If we go along the axis straight from south to north, it passes underneath the Forbidden City, causing problems for the ancient buildings there. So, in the south section, we went around to the east, completely avoiding the Imperial Palace.
It took years of negotiation to finalize the subway map. But now, they have it. Chief Engineer Yang must deliver this record-breaking system. He knows it won't be easy. Tunneling is one of the most hazardous jobs in construction. And Beijing has some of the most dangerous geology in the world for tunneling. The men of the Beijing Urban Exploration Unit labor into the night while the rest of the city sleeps. They have the dirty job of working out Beijing's dangerous geology meter by meter.
我们的工作就像这个医生一样。
We're just like doctors. Visit the site, drill, get samples, go back and go through lab tests. Then diagnose the geology conditions.
To build the world's biggest subway, work must go on 24/7. They penetrate down 40 meters to extract a 15-centimeter wide core. That core is a snapshot of the ground below. Tonight's location is Chaoyangmun Junction, the site of a planned new tunnel for Metro Line 6. There are two things the team doesn't want to find tonight: water and sand. For together, they can create the tunneler's nightmare: quicksand. Beijing is infamous for it. The pressure is on.
好，现在我开始可以口完口立即取啊，好吧。
A special instrument is used to test the water level. There's bad news. It's high. The team can only wait to find out. Is there also sand?
粘着分头分，没问题。然后有点饱和，有味儿，很湿。
Putting all this information together, a diagnosis is made. The water level is high, but they've got lucky. Line 6 will tunnel through clay, the perfect tunneling material. It's good news for this line. But Chief Engineer Yang is worried.
At the moment, everyone is talking about a collapse that just happened during the construction of a subway in Hangzhou.
Though he thinks it may have been human error, the accident is a reminder of how dangerous digging a subway is. 21 tunnelers died. Yang knows that Beijing's geology is even more treacherous than Hangzhou's. Engineers have devised a special technique to make tunneling under Beijing safer. Every tunneler knows the drill.
管超前，沿渡江。
First, the tunnel face is strengthened with a steel frame.
再开挖，墙支护，撒防壁。
Liquid concrete is sprayed that sets within minutes.
勤量拆。
And earth movement constantly monitored to check the ground is stable. Using this system, known as the mining method, and guided by a GPS laser, Line 9 advances. But the pace is excruciatingly slow. Just 2 meters a day. To finish by 2015, tunnelers need to average 15 meters a day. Yang is feeling the heat. What's more, trouble lies ahead. As Line 9 runs south, the tunnel must pass underneath Yuyuan-10 Lake.
If we employ the mining method, the sand and pebble layer is permeable. Once the protection layer at the bottom of the lake is destroyed, large volumes of water will flow through the excavation phase of the tunnel.
Water increases the risk of quicksand and tunnel collapse. It's too dangerous to continue. Yang needs to abandon the mining method and switch to a new approach, a huge underground drill, a tunnel boring machine.
The advantages of a TBM are it's fast, it's safe, and it handles high water pressure well.
The problem is, there's only one TBM in Beijing. And the team has just discovered Beijing's unique geology can be more than a match for this mighty machine. Welcome to the rush hour, Beijing style. The men in this room fight a daily battle against gridlock.
What you're seeing now is the evening rush hour. During this peak hour, there are 57 jammed highways.
Traffic jams are now part of the daily routine for Beijingers, and it's getting worse. 1,500 new cars hit the streets every day. Cameras comb the city's roads for accidents. A single crash can cause tailbacks that trap thousands of commuters. At the first sign, the controllers must take swift action, but they can only do so much. City planners hope they have come up with a cure for this car chaos. In true Chinese style, it's big. 100,000 construction workers are building the biggest subway system ever seen. Digging so quickly through Beijing's notoriously difficult soil requires specialized, high-tech equipment. In the world of tunnels, you don't get more high-tech than a TBM. This is the only tunnel boring machine currently in Beijing. It's on the outskirts of the city, at the end of Metro Line 4. The line is 28 kilometers long and connects the city's academic, business, and residential areas. The end of the tunnel is near.
My name is Gao Yuexuan. I'm the fastest TBM driver in China.
This has been a special year for Gao Yuexuan.
I hold the record for TBM driving, which is 33.6 meters a day and 568.8 meters a month.
At that rate, the team are just 28 days from completing the tunnel.
When the construction is complete, we'll be holding a party. There will be singing and dancing.
But the story of this tunnel has a final sting in the tail. In the site office, 60 meters above, someone is worried. Looking ahead at the final section, Line 4's geologist has seen the last thing he wants to see.
The geology in this section is considered quite complicated.
Beijing's site was chosen according to the ancient laws of feng shui, with mountains bordering the city on two sides. Over the millennia, rain has washed rocks down from the mountains toward the plain. The rocks get smaller the further they are from the hills. Beijing, therefore, has sand in the east and rocky soil in the west. If anything can slow down the fastest TBM driver in China, this geology is it. A TBM can easily handle sand or rock. But when there are layers of different hardness, This mighty machine is pushed to the limit. Looking at the geology map for Line 4, that's exactly what Liu Wenbin has spotted ahead. If too much forward pressure is applied, the TBM cutters work faster through the softer layers. This uneven progress causes the blades to fatigue on the harder sections below. Go too fast, and serious damage might be caused. Work would grind to a halt.
With such complicated geology, it means we have to excavate very carefully every day.
Frustrated, his only option is to slow progress down to 5 meters a day. The celebrations planned by Gao Ruixuan are going to have to wait. Above ground, the small distance they have left becomes clear. It's just 500 meters. It's a case of so close, yet so far. As the TBM works below, the tunnel passes near the historic Summer Palace. Tunneling always causes some ground movement, but Beijing's ancient buildings are safe, thanks to an idea that originated 5,000 miles away in the UK.
My name is Professor Robert Mayer.
He's known as the man who saved Big Ben. 1993. Work begins on a new section of the London Underground. The new line goes right under one of the city's most iconic landmarks.
All eyes were on the Big Ben case because it was clearly completely unacceptable for Big Ben to lean more than a very small amount.
After months of research, he came up with a new method called compensation grouting. Relying on an untried technique was a big risk, but there was no choice. Mayer's idea worked like this. Steel tubes were drilled in a fan shape in the ground, directly underneath Big Ben. As the tunnels moved forward, ground movements were measured. At the slightest sign of movement, they injected liquid cement into the earth. This stabilized the foundations. It took them almost 2 years to complete the tunnel. Mayer and his team could only watch and wait. It worked. Big Ben was saved. News of the success spread internationally. Engineers in Beijing have adopted Mayer's technique. Thanks to his work, Beijing's iconic buildings are safe. But can this city of car fanatics be persuaded to swap the automobile for the subway train? In Beijing today, the car is king. Many people prefer to sit in traffic rather than take the subway. One commuter is getting tired of it. His face blends into the crowd, but he's got a voice nearly everyone in Beijing recognizes.
我在坐地铁的时候，就曾经碰到过这样一件非常尴尬的事情。那么前面呢，有一位老大爷，他留了。
He's Luo Bing, host of the most popular breakfast radio show in the capital, and he delivers the traffic news. Even though his job is about cars, he loves the metro.
这个城市有一个
The city has a pair of invisible wings. It will fly you to where you want to be. It is Beijing's subway.
Day in, day out, he's reminded how bad the traffic in Beijing is.
西直门桥仍然是在堵车，而且呢，在积水潭桥情况也不是很好。建国门桥，我们希望把这个字“建国门”这3个字呢，真的能从我们的堵车名单上给去除掉，但是它仍然是在堵车。
Luobing can see only one solution to Beijing's traffic jams: the metro.
我觉得北京人
I don't think Beijingers really love their cars. They love the status of having a car.
拥有车的状态。
For Luobing, the key is to make the metro cool. Beijing's chiefs have realized that too. And change is coming to the metro. One place that's obvious is at the station for Beijing's airport. A design that's as futuristic as the new terminal it's attached to. Beijing's subway is being designed to echo the ancient yet dynamic city above. Line 8 reflects the adventurous new style of the Olympic Park it serves. This change to the metro was noticed by Jackie Zhu, an expert in LED technology. He also saw how the new metro was drawing a younger, more fashionable crowd. He had an idea.
We have beautiful stations and highly technical and intelligent trains. I think it would be very disappointing if passengers had to experience dark, endless, and boring tunnels.
Jackie's team developed a series of LED panels to be mounted on tunnel walls. When a train goes past them, these produce the illusion of a moving image.
Are arriving at Fengchengmen Station.
Our invention really does make the subway look good. Not only does it look cool, it is in fact cool.
But then, they hit a problem. Like a zoetrope, this amazing technology relies on an optical illusion. Looking through slots cut in a wheel, the eye and brain piece together a moving image. This illusion relies on the wheel moving at a constant speed. At first, if the train did not travel at a steady pace, black lines appeared in the image generated by Jackie's LED technology. In the lab, they're working on secret technology to solve the problem. The magic happens inside each panel. For the optical illusion to work, the frequency these lights flash at must be continuously altered depending on the speed of the train. So, sensors on the tunnel wall record the speed of the train. The slower it goes, the faster the sensors tell the lights to flash. Jackie and his colleague are using this testing wheel to make the minute adjustments the system needs to maintain the illusion. It seems to be working. They have ambitious plans.
I hope every corner of the subway tunnels will be covered by our advertising system.
The high profile of the metro project has got Chinese innovators thinking. One scientist is working flat out to perfect a security system he hopes will be used in the world's biggest subway.
My name is Stanley.
Observing world events, Stan believes the biggest security threat to Beijing could be in the metro.
Metro systems are the focus of attacks from terrorists, and it's also a place where criminal suspects are going through. So we pay a lot of attention on the security of metro systems.
Stan's plan relies on a technology called facial recognition. Facial recognition software looks at a face and analyzes points scientists call landmarks. The distance and angle between the landmarks is measured. This information is put into a database. When a face is caught on camera again, the computer searches the database until it finds the best match. But Stan's system has a weakness. It cannot detect individual faces in very large crowds, something the Beijing Metro is famous for. But one day, Stan had a brainwave. The perfect place to use facial recognition would be the one spot passengers are filtered to single file: the ticket barriers. He has come to Beijing's largest train station to test his theory. He's placed 4 of his students on today's wanted list. He registers their images and names.
Okay, go.
He orders them to disperse. They have 30 minutes to get through Stan's security system without being caught.
We want to create technologies that is smarter than criminals.
But who will be the smartest in this test? Each face is checked. If there is a match, the suspect appears in the corner. The first person is caught. But anything less than 100% is a failure. The test has been running for 10 minutes. There's still one person to go. Her name is Xu Min. She's a 23-year-old student. As she passes the checkpoint, the camera picks up her image. Within milliseconds, it has analyzed her facial landmarks against a database of potentially millions and found a perfect match.
Good.
Stan catches his last suspect.
Today's test is a great success. It seems like science fiction, but we make it a reality.
Stan hopes to eliminate any problems in the system by 2011. But before Metro chiefs can even consider applying Stan's innovation, engineers must complete the world's most high-tech subway. And they've hit trouble. Back at the construction site for the world's biggest subway, work is steaming ahead.
My name is Wei Baolin.
Wei is in charge of laying Beijing's new underground train tracks. That's 32,000 rails in all. His job is all about precision and speed. Wei Baolin is 5 kilometers from the end of Beijing's most important new line, Line 4.
There are 63 kilometers of underground tracks on Line 4. I can feel the pressure of the schedule now.
He's got just 2 months to finish the entire line. The clock is ticking. However fast Wei needs to go, his tracks must still be laid with precision. He uses a special welding machine that lays up to 40 rails a day. A laser guidance system ensures the rails are totally straight and fully aligned. Computerized systems allow connections measured down to the closest micrometer. Put these together, and it means the ride is more comfortable for passengers. And train wheels don't wear so much. But Wei's machine can't help him with a problem above ground. In the planning stage, subway designers always try to place new lines under main roads. That way, they avoid the massive foundations of skyscrapers and tower blocks. But one consequence of building the world's biggest subway is that tunnels have to go under thousands of offices and homes. The bad news for Beijing's residents is that vibrations from subway trains can pass upwards through the ground. Luckily, there is a special research facility in their city. And this man. When Professor Liu Weining learned that Beijing planned to build one of the densest underground railway systems in the world, he knew the city would need special testing facilities.
一般来说呢，我们人们可能会认为地下的线路
Generally, people think that having underground trains means you won't produce as many vibrations. In fact, underground lines may not be as noisy, but their vibrations pass to a much wider area.
So he purpose-built the only lab of its kind in the world. In an underground tunnel, this machine replicates vibrations made by Beijing's metro trains. This facility is needed because of a strange phenomenon that is a big problem for metro builders. To teach his students about this mysterious obstacle, Professor Liu came up with a small demonstration. Imagine these springs are different buildings. You can barely see it, but each one is vibrating at its own natural frequency. The springs are on a platform. Professor Liu is able to adjust the frequency at which the platform vibrates. When the vibration frequency of the platform matches that of an individual spring, it bounces wildly, while the others remain relatively still. Essentially, this is what happens when the vibration frequency from a train matches that of a building. This is known as resonance. Because each building has its own frequency, Liu has to tailor-make special rail combinations that deaden vibration. Only the right combination can stop resonance from occurring. To stop trains disturbing particularly important buildings, Liu must vary this rail by rail, a mammoth task.
Every position, every building, even the structure of every room has its own vibration frequency.
Every building could need a different combination of rail attachments. To ensure Beijing residents are not disturbed, Liu has to crack that code. He runs test after test to record the vibrations coming from his tunnel. He leaves no stone unturned to find the right rail fixtures for the right job.
In many cities, the subway wakes people up at 5:30 in the morning, and they can't go to sleep until 11:30 at night. Whenever we think of the fact that our work is solving these problems, we all feel really proud.
With Professor Liu's tailor-made tracks, Beijing's planners know it is safe to build beneath populated districts. Nowhere is this more important than on Line 4. Beijing's most important new line passes under many residential areas, meaning there are more of Professor Liu's rails here than anywhere else. That is another headache for Line 4's welding supervisor, Wei Baolin. With every day of construction costing Beijing millions of dollars, delay must be kept to a minimum.
The huge number of vibration reduction tracks brings equally huge difficulties to my schedule.
When Wei Baolin's tracks are complete, the trains running on them will be controlled from this room. It's the beating heart of Beijing's new metro. But can it handle the 8 million people a day predicted to use the world's biggest subway? At maximum capacity, 290 trains run on Beijing's lines. They are all controlled from here, one of the few so-called integrated command centers in the world. It is the metro's brain. Each and every subway train is tracked from this one room. For the first time, the entire system can be seen at a glance. Extra capacity can be added within minutes. Faulty trains can be withdrawn and immediately replaced. But will this be enough? Beijing's plan is to increase passenger numbers by 400%. Even at today's levels, the system is straining. To help ease that strain, Beijing has installed the world's most advanced signaling system. The new signals rely on something called moving block technology. In the old system, trains were stopped at set points. When one train entered a section of track, no other was allowed to follow. The average gap between trains was 5 minutes. With moving block technology, an onboard computer means trains can communicate with each other. They move together in close formation. The average gap between them is reduced to 2 minutes. Tonight, while Beijing citizens sleep, York Bisanak has come to push this system to its limits. He wants to find out exactly how close he can make these trains run without activating their safety brakes.
Such a complex system you cannot only test in the test lab.
York disembarks. The test begins. He waits anxiously for the two trains to loop back.
So is the reversal okay? Okay, the first train is coming and passing by. The train should not stop. Okay, I can already see the second one coming. Okay, very good. So we just have a headway of 32 seconds passing the station.
It's a great success. York has proved trains could run on this track with a gap as small as 32 seconds. Potentially, trains could run almost 4 times more often, easily enough to match the targeted 400% increase in passengers.
I'm happy with everything. This project so far was running very positive.
With this intelligent signaling system, trains can deposit as many as 4,000 passengers every 2 minutes onto busy train stations. With so many people arriving at once, it can look like chaos. Every one of Beijing's 17 million citizens is a potential metro customer. How can you predict the way they will use the metro when every one is different? Metro chiefs didn't just want to plan for numbers. They wanted to make the world's biggest subway really fit the people who'd be using it. They turned to this man, an expert in the new science of pedestrian modeling. Dr. Shi observed the Beijing commuter in his natural habitat. Together with his colleague, Dr. Wang, he examined hundreds of hours of footage. They separated Beijing commuters into categories: Beijing young male, young female, senior, tourist. They measured the speed at which people walked, their behavior in crowds, on escalators, and in lines. Their research revealed some surprising facts about Beijingers.
Interestingly, Beijing people walk much faster than we have expected.
In fact, the research showed Beijingers are the fastest walkers in China. Their data is fed into station blueprints. Each of these dots represents a metro passenger. But not just any passenger. They are Beijingers.
Using this kind of approach, making the design more humane, then you design for the people, not just a design for capacity.
The first test of their system arrived with a new interchange station in the south of the city. When completed, the station will handle over 100 million passengers a year. Designers called on the doctors to examine their plans. Would the station be fit for purpose? Using their pedestrian modeling, they found something surprising. A bottleneck was occurring in one of the worst possible places: the platform.
Without enough capacity on the platform, with large crowds, that could create a dangerous situation.
Dr. Wang recommended a second design with a subtly angled platform. They ran their software and saw an amazing effect. The bottleneck disappeared. This should be the first of many times pedestrian modeling will be used on the Beijing Metro.
The engineers work behind the scene in designing the metro system and planning the metro system is not highly visible, but we're happy to be the hero behind the scene.
The biggest subway in the world is on track.
It's unbelievable when you see such a plan in the timing they want to do it. But I'm pretty sure they will do it.
Gridlock is disappearing as 2 new lines a year open. The savvy crowd are shunning the road for the new fashionable metro. But this is not the end of the story. This man-made marvel is going to double in size again.
In the future, by 2050, it will be 1,000 kilometers long. It's got a bright future, and we are confident we will build it well.
The future of Beijing's 17 million inhabitants will be built around the metro. The destiny of the city above relies on the success of the mighty system below.